Okay, today is called a z-score. If you have a 1.0 z-score, you're here. Now think about that. Do you get that that means you are above the average? Okay, now this could be a good thing. Usually you want to be above average. Unless it's like how many accidents you've had. You know, then one above the average is really not great. One standard deviation above average. Okay. And if you're at like a 3, you are way above average. Okay, so if this is a good thing, like how many hits you get in a game, and you have a 3, that means you are way 3 standard deviations above normally. You know, you're on the teeny tiny percentile out there, super best. Okay. What if you're at a -1? What do you think that means? 1 standard deviation below. Below what? Below average. So if you're at a 0, you're just exactly at average. Okay? So if this is something like, again, something good that you want, like hits in a baseball game, and you are at a z-score of 0, you're just right at exactly at the average. So what's a 1 mean? It means you're 1 standard deviation above average, which means you're pretty good. You're above all of these people then. You're up in here. Okay? You getting what it means? All right. So let's say it is about car accidents. Hint. You don't want them. And I've got Aaron and I got Lisa. Neither name is in the room, so we don't have to feel bad. Okay, so Aaron's at a -2 and Lisa's at a 1. If it's about accidents, what does that mean? Well, it's about standard deviations. Afton, can you explain who you'd rather ride with? Because in accidents, he's below average. How far below average is he? 2 standard deviations. So if you were to look at a normal curve and he'd be like here, that means he has very low amount of accidents compared to most people. All right, let's go to the actual slides here. Here's another great example of this. You can compare things like an SAT score to an ACT score. Do you get that they are completely different scores where the ACT is a 36 max and the SAT has a 1500 max? You can't really compare them, or can you? You can compare them. 1600. Okay, sorry, 1600 max. All right, so back to, let's look at this and read it thoroughly, and then I'll explain how we'd use a z-score to compare them. Haley's got a 680, underline that, on the SAT. And it's on the math part of the SAT. So it's actually, I think it's, just wait. We'll get there. So just hold on. Well, they just did the math part of the SAT. So they just clarify, the SAT has 2 parts, math part and the rest of it, which is basically English and reading. So now we're going to compare that. The distribution of SAT scores in a reference population is normal, meaning it follows the bell curve. Mean is 500. Ooh, that's important. And standard deviation is, let's say 100? There, 100. Okay, that's what you need to get a z-score. So then we'd be able to get Haley's z-score. And then we compare it to this other kid who took the ACT. And normally, again, kids would be like, you can't compare those two. You can if you make them both into a z-score. All right, so Cody takes the ACT and gets a 27 on the math part. And it says the mean of 18, not true, but let's imagine it was, and standard deviation of 6. That's pretty close to the standard deviation. Find the standardized scores for both students. What that means is you find the z-score for both of them. And do you get if one of them has a z-score of 1, they're 1 above the average, 1 standard deviation above. And what if the other one has a 1.1? Well, they are a little higher than one standard deviation score above the average. So then you'll be able to super easy compare. Haley's got a 1 and Cody's got a 1.1. Well, Cody wins. See what I mean? All right, so let's move on and find out what we actually would be able to tell. I've talked about this stuff enough. I don't think we need this slide. On to the next one. This is how you actually calculate a z-score. All right, so let's go with a simpler one, shoe size. I've said that I think the average shoe size in here is a 9. And you guys are all either above it or below it or exactly at a 9. Okay, now, which of these three little symbols is that average? Is it the X, is it the mu, or is it the theta? No, this isn't a theta. That's a, anyway. It's this sigma. There we go. Okay. So I got X or mu or sigma. Is it the top one, the middle one, or the bottom one? Mu. Mu. I never thought I would have a kid sound like a cat, and it was the correct answer. Okay, good. Now, how about the sigma? Well, I've said before that I think that the standard deviation of your shoe sizes would be about a 2. So let's put a 2 there for the standard deviation. Now, you personally, you know what your shoe size is. That's the X. Okay, so I'm going to do an imaginary kid who's got a shoe size of 10. No, just for right now. I'm going to show you what it would be, but you do it for yourself. You know what your shoe size is. You go 10 minus the average, which is 9. And then you divide it by the standard deviation, which is 2. So again, for my scenario with size 10 feet, that's not actually me, but for my imaginary kid I'm doing this for, it'd be 1/2, which is a 0.5. What does that mean about the kid? They are above average by about a 1/2 a standard deviation. So, you know what this looks like, right? Here's average, and here's 1 standard deviation. And if you want to know where you fall, this kid falls right in there. And so, actually, he's in the upper. You could figure out exactly what percent. Way above half the people, though, because it's 1/2 a standard deviation above. And if the standard deviation goes out 2, this is a 9, this is an 11. And you can see what percent of the people you're in front of. You're in front of all these people. Okay. Now, you just hopefully figured out your own z-score. How many of you were at 0 or a positive number? Raise your hand if that's you. All right, I actually want to count. So if you were at a 0 or a positive number, meaning you were at the average or above it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, thank you. How many of you were at a negative or a 0? I'm going to count the 0 people twice. You're at a negative or a 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It seems like more people are below that number. But, you remember the whole, do you think I actually took the averages for this room exactly? No. So, of course, I was off a little bit. So, my average probably isn't really 9 in here. It's probably more like 8.5. Okay. All right. So that's how you calculate a z-score. And this formula will not be given to you on the test. You have to remember it. Try to remember it's your score minus the average score divided by the standard deviation. All right, so let's do it for the ACT. Everybody go off to the side. I can tell you the average ACT score is a 20 nationwide. The average is 20. This is for ACT. No, that doesn't matter. What average is a 20. The next thing is the standard deviation. If you want to know that separate question, which is not included in our calculation, the max on the ACT is a 36, but you don't put in 20 out of 36. Okay, so standard deviation For the ACT is a 5.5, I'm rounding. Now, all we need is a score. All right, so some of you may have actually taken the ACT score, which you had a chance to do, but I don't want to make you tell everybody in front of everybody what your score was. And if you tell me it was a 37, I know you're lying because 36 is the max. But when you took it, you were probably like a freshman and you were comparing against seniors. And so imagine a kid raised their hand and said, I got a 27. Let's figure out their Z-score. If they had a 27, let's figure out their Z-score. Goes pretty quick, doesn't it? You just have to go 27 minus the 20 divided by the 5.5. I can do some of that in my head. 7 divided by 5.5. What is 7 divided by 5.5? I'm going to round it to 1.3. If they had said 1.3 is my Z-score, you could have been like, oh, so you're a little more than 1 standard deviation above normal. But then if you wanted to really know, you'd look at normal and go, normal on an ACT is 20. That's the average. And here'd be 1 standard deviation. And this is that kid. 1.3. They're about there. And now you have a much better perspective on how good a score that was. They're here, and you could think of it as they're ahead of all of these people. And you could even figure out exactly how far ahead of all those people they are if you wanted to. But Z-scores are particularly good for comparing things that are hard to compare. Let me give you an example. Last one, and seriously, I think after this, you will get why you need them and how to calculate them. Listen, guys, almost done here. Stop talking. Sorry. Okay, so you got 2 science teachers. Imagine you take science from Bob, Mr. Bob, and his science test is out of 120. And you got an 82 out of 120 on his test. We're going to have to know more about this test, but Mr. Bob's test is harder than Mr. Jim's test. Mr. Jim's test has only got 50 questions on it, and this kid got a 44. Now, how do you tell, though, like what's fair? Well, you gotta know the averages because you can't just divide them and see. You know what I mean? Like if normally you just divide them and see who got the better percent. But we know that Mr. Bob's test was a harder test. You know why? Because we know the average score on his test. Okay, so the average score here was a, let's see, out of 120, let's make it a 60 out of 120. Like half right was average in his class with a standard deviation of 8 points. Over here on Mr. Jim's test, easier test, the average was a 40 out of 50 with a standard deviation of 4. So who really did better? Now you can actually compare these things as long as you have their averages and the standard deviations. How? You're going to get each kid's Z-score. I'll pause for a second. Figure out each kid's Z-score. We can review here now. If we compared Mr. Bob and Mr. Jim's tests, this kid got a 2.75, this kid got a 1. This kid's way, 3 standard deviations almost above average, and this person's only 1, so this person had the better score. That's z-score. We have finished z-score now. And now let's talk about inverse normal. That's the one we did most recently. Inverse normal is the kind where you're going to say, I want to know what the 60th percentile is, and then I'm going to give you the average and the standard deviation of something, and it'll tell us the number. All right, those are the 3 things you enter. But remember that this would tell me below this number. So if I really want the top percent, you got to do 1 minus that. Okay, so now let me give you an example problem, see if you can enter it right. I want to know, I want to be in the top 10% of the ACT scores. I know the average of them is a 20 nationwide, and the standard deviation is a 5.5 nationwide. I'm rounding here, but use inverse normal to figure out what score would put you in the top 10% of ACT scores. I'll pause for a second while you do that. Be careful with that first number. Okay, here's how you should have entered it. 0.90. If you put in 0.1, you were finding what would put you in the bottom 10%. And I would guess you would realize when you got the answer that it didn't make sense. And then 20 comma 5.5. And your actual answer to that. Heffernan, what did you get? 27.0 anything. Let's just round it to 27. Would you guys agree it would round to 27? Okay, good. So a 27 ACT is in the top 10% of all ACT scores. I know some of you are already there. If so, nice work. And if you want to make it even better, there are ways to study. I'd happily chat with you about that after class. And you might be like, well, I'm already in the top percent. Why would I care? Because at my daughter's college that she went to, for example, if you got a 31 ACT and you go there, they would give you this huge scholarship. So, all right. So then the last kind is the kind where it's PDF or CDF. Do you remember which one it is? I heard one person say P and one person say C. So what do you guys think? You have to join team CDF or PDF? Which one is it? It's C. It is CDF. All right. So find the one under distur that is got CDF in it. And I believe it says, is it norm or normal or what does it say? Right in front of the CDF. For a word normal, thank you. Normal, normal CDF. It's got 4 things. If you know all 4 things, you'll get these right. They're really not that hard. But what are the 4 things? Well, the last 2 in all of them have been the average and the STDEV. So then what are the other 2? Lower and upper. Since I've been on an ACT kick today, I'm going to continue with that. Let's do the averages, 20, standard deviations, 5.5. And let's say there's a lot of kids in Minnetonka that score between a 28 and a 31. Well, let's do that. 28 and 31. And then we got to figure out what to do with this answer. What is it? But you'll see. A lot of kids in Minnetonka score between a 28 and a 31. Okay, Becca, what did you get?
0.05.
0.05. Now, I'd like to know what the heck that means. First of all, did anybody else get 0.05? Fair number of people. Do you guys agree it's 0.05?
Yeah.
Okay, so what is it? 5% of what?
People in between 28 and 31.
5% of people in the nation. Good, not people in Minnetonka, because Minnetonka's average isn't 20. But nationwide, 5% of kids will get scores like that. And do you get if we do this number for Minnetonka and it says that we have like 60% of kids in that zone? That'd be pretty cool. It'd be like 60% of our kids score in this really high range. We're only 5% nationwide score in that range. Okay. All right. That's a review of how to do CDF and inverse normal and the new thing for the day, which was called the Z-score. I want to end with one last Z-score. You ready? I just wonder if I give you a scenario, if you can compare them. Do you get that men's sizes on shoes are different than women's sizes on shoes? Okay. So if I have this one kid and he's got a 9, and we're going to name him Bill. And then there's Karen, and she's got an 8.5 shoe size. Do you get that men's and women's sizes are different though? So I got to go with, if I'm going to really compare them, I'm going to use a Z-score. Because the average for a male is, and the standard deviation is, and the average for a female is, and this average and the standard deviation for a female is. And we might find that even though Bill has a size 9 and Karen has an 8.5, that she's actually way above average and he's below average or something. So it's, you can compare them so much better if you do a Z-score. All right, so it's, remember it's X, which is whatever the score is, minus mu over sigma to get the Z-score. But I need to get you numbers that we can all agree on for average and standard deviation. I'm going to pause for a second.
5.7.
Okay, and here's how I would have done this. Karen's actual is an 8.5. I subtract the average, which is 8.5. And isn't that 0? I think when you typed it in wrong, you probably typed it in wrong without the, because the top is just 0. What's 0 divided by 1.75? 0. Karen's got a 0 Z-score because she's right at average. And that makes sense. But Bill, I think, is going to have a negative Z-score. What'd you get? Still haven't done it. Okay, then I'm going to walk you through it. Get your calculator up. So here's what you do. You take the average, which is 10.5, and you subtract, you take the 9 and subtract the 10.5, and then you're going to divide by 1.75. Pause it. So we got our numbers for Bill. He's a negative 0.85. That means below average. How much below average? About 1 standard deviation below average. And Karen is right at average, and so she's at a 0. So there's a professional way to compare and see when you have two different things to compare, like two different normal sets of data, and it's the Z-score. All right, cool. You want to know something cool? You just learned the last new thing. From here on out, it's all review for the final. So, congratulations. As soon as you have taken the final, you've made it through Honors Higher Algebra. Okay. So, starting tomorrow, we do some serious review. But today, it's just another day. You got a Schoology quiz. Get that done. It counts. Homework scores are somewhere in the neighborhood of 0.5% per Schoology quiz. So you're blowing them off, you're knocking your grade down. At a little less than that, but it's close. And that's all I got for you for today.